today we're going to be designing payment gateway. And first of all, let me discuss what payment gateway mean in our case. Let's say you're a marketplace, for example, Amazon, that's handling client payments. In order to handle payment, you need to handle communication with several sites. First of all, bank that issued cards to your user. We're going to be talking about credit card payments, for example. Your own bank that's going to be a recipient of payment, and some number of intermediary banks. In order not to handle this complicated communication between banks, we're gonna decouple it from our own system and give away to third-party solution. Third-party payment providers like Stripe handle pretty well these things. And so this concludes our payment gateway. Now let's talk about functional requirements. Of course, we need to cover payments. We need to handle payments that go in our marketplace. What I mean by that is handling client payments to us. But also as marketplace, we have an obligation to deliver payments to merchants, our sellers on our marketplace. So we also need to cover handling payments that go out of marketplace. And because here talking about financial data, transactions, we need to cover reconciliation of this info between us and our third-party payment provider. So reconcile with third-party payment provider. All right, I think it's good enough. We can move on to non-functional requirements. Now let's mention some non-functional requirements. First, what you want to cover is availability, because you don't want to make user wait or even maybe come back for payment in some time, like a day or an hour, and because user can just choose another marketplace and it will not give him a headache of this kind. You want to also go for performance, because payments need to be processed fast. I don't want to waiting for minutes seeing my credit card processing. It's really boring and tiring stuff. Also, you want to be scalable. Who knows, if business goes good, you might be handling millions of transactions per day or more. All right, good. We covered some. Okay, let's make this payment provider. We covered requirements. It's not all that can be discussed in payment gateway design, but I guess it will be sufficient, at least for now. We may be able to add some more after we discuss design. Now that we have discussed some requirements, let's talk about high-level design of payment gateway. All right, let's move a little bit down. Okay, first of all, we want to have some first step service, and we call it payment handler. I think it will be a good one. Our payment handler communicates with outside world, or outside services, marketplaces. Let's put it somewhere here in the blue. Great. All right. Call it marketplace, but it will be of course some service in the marketplace. We're just not gonna distinguish from this name. All right, great. Payment handler. Payment handler could send a request for payment to our third-party payment provider, but in order to decouple our system, we will have intermediary between payment handler and payment provider. So let's call it payment executor, for example. All right, and our third-party service. Okay, let's move a little bit to the left. All right. Let's create. Okay, let's put it in green. Payment provider. As discussed before, it's a third-party service that we're not gonna be developing. All right. Okay, let's fill in information. I'm gonna call this payment executor. Oh yeah, I totally created yet another box. Oh my god. Okay, great. Too much services here. All right. Also, payment handler wants to keep track of what's happening with accounts and account balances. So for this, we're gonna be creating another service, which we're gonna call accounting service. Or just accounting, I guess it's self-explanatory. Also, as we discussed, we need to be handling reconciliation of transactions. And in order to do it, we must compare our own books in accounting with information that payment provider has on us. So let's create some set of reconciliation service. It is gonna be handling this is gonna be handling checking transactions on validity. Okay, all right. And it's also gonna be communicating with payment provider. All right, great. Okay, let's call it reconciliation service. Reconciliation service. All right, great. Now we need to put our data somewhere because we cannot be possible keeping a lot of transaction information and order information just in application. So let's talk about some databases. I think we need separate one for accounting purposes because it's going to be handling a lot of info on different transactions happening for different wallets of users and so on and so forth. All right. So accounting service will be handling this one. I think reconciliation service can talk with accounting, or maybe just go to database. So let's keep our options open. Say that it might go to database. Also, payment handler, of course, must have some database to keep information about order. Right, let's add it right here. How to call it, I'm not sure. Maybe some payment info, something like this. I guess it's must go for payment and order information, but for simplicity, right, let's write this here. Okay, here we're gonna keep account info. Right. Let's track our request when we get one for some payment. First of all, it mentions that one request for payment may include several orders that are going to be paid for, and that means that one credit card charge is going to be distributed to, for example, several merchants. In order to correctly process it, we need to keep our payment information in database and associate several orders with one transaction charge. All right, now we're gonna be sending from our payment handler information to payment executor, and our payment executor is gonna be communicating with payment provider. Alright, now let's talk about problem of double spending. What it means is, for example, our payment executor did not get a response from payment provider, or some network problem, or maybe payment executor died and got up, or some whatever issue happened, and we send a request to payment provider, but we don't know if it was if the payment provider got it, or maybe we don't remember even that we sent it. Whatever, something happened, and basically what we do is we send another request with same information. So what's going to happen is our user going to be charged twice for same purchase, which is of course a bad situation. So in order to handle this, there is procedure. First of all, our payment executor is going to communicate to payment provider some ID that's going to stand for our payment order that we want to handle. This ID is going to be translated in payment provider's own database to some token. That token payment provider is going to send back to us, and we will remember it and keep in our database near our payment together with our payment information. Alright, great. Now repeating our path, payment handler is gonna send ask payment executor to execute some transaction, and with information on amounts to be charged, payment executor is also gonna send token information that he got from payment provider previously. And now, if for example some issue occurred, we sent two requests. Payment provider not gonna charge second iteration, because he's gonna understand that it's same payment, and it's gonna see that this is repeated. Now let's talk about some metrics. First of all, let's discuss transactions. We will be handling 500 transactions per second on average. We also have some peak hours where our load will grow in several times. I think it could be around maybe 4x multiplication, so about 2k TPS in peak hours for Black Friday as one example, or whatever kind of big sales. Alright, also we get an API calls, like for example payment status or maybe updates. Let's multiply our average estimation of transaction by 4 and go with it. So it will be also 2k, but this time RPS on average. Of course, we can talk about 8k RPS in peak hours as general multiplier. All right, let's also specify what we're talking about: payment status, updates, etc. We need to store a lot of data, so let's check how much it will be. Let's focus on RPS for now, and average RPS is 2k. Let's say some requests, of course, will be less informative than transactions, so maybe we can cut in half, because not on every request we're going to be writing something. I think it will be a good one to maybe half of request will be with writing of some data. So let's go with 1k RPS. So I'm going to be generating some data, and let's estimate our data generation. One request generates, say, 1 kilobyte. All right, now that means that our 1k RPS with 1 kilobyte for every request will get us 1 megabyte of information in second. Okay, let's go for a day's estimation. So we will need to multiply by 60, 60 and 60 seconds, 60 minutes and 24 hours. All right, we will get or save some estimation. Let's recall that we can divide by around 1000 to get 1 gigabyte. So it will be 36 and 2.4. Yeah, I think it's correct. Hope that it is. Gigabytes, which will give us around 72, 74, and around half. So let's settle for around 100 gigabytes as an upper bound. It's more like 90. Let's go with maybe 95. Like 400 for easier number to wrap around. Alright, great. Now we have our space estimation. We have our RPS. Alright. Great. And our TPS, because we're talking about payment system, we need to start with TPS. Alright, good. Now that we figure out metrics, let's talk how we're going to be handling them. First of all, let's talk about communication between services. Due to big load that we have here, it will be a good idea to have some intermediary between services where it's possible. So, for example, I would suggest to put a messaging queue between payment handler and payment executor. And this will allow for them to have some stack time because payment handler can just put orders into messaging queue without waiting for response from payment executor. And also payment executor can take orders as possible, not to be swamped in them, and also put information about, for example, tokens that he gets from payment provider back to messaging queue for payment handler to take away and process as he goes. Also, we're going to be communicating with accounts of users in cases where it's needed, because as a marketplace we can have some bonuses, our own system of money. I don't know, something like this, maybe some interesting promos that take some scores that say a marketplace scores, and so we also may get a lot of load on this side. So messaging queue between them will be a good idea. Reconciliation service is going to be running in the background, and it's not needed in real time. So I guess it's sufficient for them to communicate as is. So maybe we need to monitor this and think about if we need here also to add messaging queue here. Now to databases. Of course, we have a lot of info we want to store every day, but we need to recall that payments are happening right now and right here, and most of load goes in real time. So it will be good a good thing to add cache here for our payment handler. This cache will store information about payment orders, because like our marketplace is going to be asking for payment status, updates, and so on. And also it will allow payment handler to easily take and repeat some orders or whatever we need to streamline process to payment provider. So cache will be essential for us to not load our database with a lot of read requests. And of course we can offload our information step by step, not all on once, to database. All right. Now let's think where we might need. I think for payment executor, it's also a good idea to keep cache, because on times like Black Friday, he will be, maybe a third-party provider won't be able to process in time, and we need to store some data in cache, so not to lose it in a swamp. For accounting purposes, I think we might consider caching, because if we have some active accounts that are going to be touched a lot, we would want to offload some amount of work to cache also, so not to hit database. But it's a smaller thing. I think the first one would be payment handler cache, because a lot of orders going through here, and we need to put them in the cache. Also, we can communicate between marketplace and payment handler with messaging queue. All right, now let's talk about our database. Really what you want here is scalable solution with also heavy writes and reads, because I think a lot of of course we offload some to cache, but still we can have like too old or maybe some specific information that needed to be stored in database. So we still need to consider two cases, but of course it's now easier. And the first thing that comes to mind is about handling storage, because a lot of data is going to be stored in here for several years. We would need to use sharding in order to separate our database into pieces that can be safely stored in different clusters. I think ID-based sharding will be okay for us because we talked about cache here, and ID-based sharding would be bad in cases if we didn't have cache, because like recent orders are the ones that get most read requests, but they will be stored in cache most likely. So it's okay to go with sharding by ID. Or you can just go with sharding by geographical location, for example, maybe some combination of those two, because the problem we are solving here is storing a lot of data. As for specific solution, I guess some SQL, like for example, PostgreSQL can be a good one. You also can go for Amazon DynamoDB. I think it will be good too. So like, you just need to think about where you're going to be storing terabytes of data, because it's like 3 terabytes per month. It's not like super great, but it's a lot of data and you need to handle it. But you really want to keep most of it is not going to be accessed a lot. So maybe you can even offload some of this database to storage like S3 solution. But it's like you need to think if it's really possible, because maybe some information is going to be used often, not super often, but often enough, so you don't want to keep it in somewhat a cold storage, I would suggest. Okay, so messaging queues between services, caches everywhere, I guess. Okay. As for accounting database, it's also going to be pretty big, because there is a lot of accounts and moving around of plus debits and credits between them. I think we also need to use sharding, and it also can be by ID or geography, or maybe some combination of those two. And it will be sufficient, yeah, because I think accounting will get maybe same amount or maybe even less. So I'm not sure about less, because it's like a lot of transactions. So let's go with the same amount of information. All right, good. Our reconciliation service will be running in some background, and it's like just a part I think we needed to cover, because it's very important to reconcile when you talk about payments. And we just need to keep in mind that this service is need to be implemented and used. But it, of course, not suffering from load as a client level load. It mostly needs to be able to process a lot of data. So maybe some also big data solutions can be discussed on this end, but it's out of scope of our design. All right, I guess it will be sufficient. So, okay, moving on to the next section. Now let's discuss if we met all requirements. Handling payments that go in. Of course, we handled payments that go in because we just got order from our client and we processed it as designed. About handling payments that go out. It's also payments that we are going to be doing towards our sellers. sellers. Because we as a marketplace must wait for about a week or several days, depending on item and situation, before sending payment toward the merchant. So for this, we can also make use of our infrastructure by just keeping info about it in accounting. We're going to be storing information that we did not yet send payment to certain merchants and already sent to others, in order to make sure that we don't miss anything or don't like pay twice. And utilizing the same infrastructure, we can create payment and just send it to merchant. We can of course pre-aggregate them because like you one seller get a lot of orders in like 1 unit of time. So we likely be making much less payments than our clients do in one iteration. So yeah, great. Reconcile with payment provider. For this we have reconciliation service. We don't discuss it in great detail, but generally it will be something like this. We ask for transaction information from our payment provider. Each provides us with like maybe file or files in, say, for example, JSON or whatever. And then we use this file to merge. We remember that we have for every payment we have tokens that payment provider gave us. So we can use it to merge this file with our own information in database, and transaction by transaction go through it and make sure that everything is okay as it should be. And also check our internal books and accounting, like to see if maybe errors is in accounting, something maybe happened here. Okay, about non-functional requirements. Availability. Messaging queues and like replicas of our servers allow us to be available performance. I think decoupling of services and messaging queues, as well as, of course, cache, allow us to perform pretty great because we like keeping a lot of load on cache, which is fast because it will be something like, for example, Redis, memory based on memcache. So like cache will be stored in RAM. So it's like the fastest way to access something. Scalability. As for scalability, of course, yet another one on replicas. We're going to be replicating everything. And a database is going to be sharded, which allows us to keep a lot of data and scale well with it. I think that's it. That concludes our system design of payment gateway. Thank you for being here. Click like button and subscribe. Thank you.